Due to some technical issue, I need to stop the video in the middle. So sorry for that. So here is the part 2 of the video and part 2 of the class. So I will continue the discussions from where I left. Please see both the videos one after the another. So see what we are doing. We have a, so when a liquid boils at a boiling point. Okay, now the boiling point, and what happens at the boiling point? Suppose there is a liquid. Now when this is the vapor pressure and this is the external pressure. Okay, when at the boiling point, suppose the boiling point of this liquid is 100 degrees Celsius, simple water. So at 100 degrees Celsius, what will happen? The vapor pressure of the liquid will be equal to the external pressure. Okay, so this is the thing at 100 degrees Celsius is happening. Now intentionally what we are doing, we are, see, at lower, now I want to boil this liquid at 90 degrees C, but how it is possible? So now I want to achieve this state where the vapor pressure will be equal to external pressure at 90 degrees C, but it happens in 100 degrees C. So I need external pressure to be applied or external pressure to be reduced. The pressure is reduced with the help of an water pump or vacuum pump. So now the external pressure, suppose, is so at 90 degree the vapor pressure will be here. With increase in temperature, the vapor pressure is increasing, becoming equal to the external pressure, and the liquid is boiling. Now what I by reducing the pressure, what I have done over here is I have made the external pressure over like this, I have reduced it. Now at 90 degree, what will happen? The liquid has attained the vapor pressure has attained the external pressure. Now at 90 degree only this solution will boil. Okay, so like this method, what is happening? We are actually separating in the soap industry it is used to in soap industry, one of the very important component is glycerol. So glycerol, how it is separated? Glycerol is separated from spent lye. This spent lye is an impurity. So from the glycerol, the spent lye is separated by using this method only. So there are so many types of distillation. See, there is another type of distillation, that is stream distillation. So how many types of distillation we have read? Fractional distillation. Before that, simple distillation, fractional distillation, 2 types of distillation. Third type is distillation under reduced pressure. Now fourth type is stream distillation. This is the last part of the distillation. Then we will go to see. So what are the types? I have already told we will discuss. We have discussed sublimation, we have discussed crystallization, and now we are discussing distillation and the last part of the distillation. Then we have differential extraction and chromatography. So in this chapter also we will read both of them. See, after stream distillation ends, here is the differential extraction and this is the diagram. And then we have chromatography, adsorption, chromatography. There are various types of chromatography that we have to discuss. Okay, now why we are studying this from NCERT? We are studying this from NCERT because see the diagrams what are there in the book. In NEET, these diagrams will come. If we study it from any other book, then the diagram, it will nearly match, because other books they have suppose different diagram rather than this. So they may have different examples, but in NCERT these examples are given, so there is a high chance that questions are coming from these examples on only, that what type of purification method is used to separate spent lye from glycerol. Then you need to give this distillation under reduced pressure. 4 options will be given. Now see, this is the setup. What setup? Distillation under reduced pressure setup. Okay, liquid will boil at a temperature below the temperature vapor pressure. How we are attaining this? What we have discussed just now, that is distillation under reduced pressure. Now let me show you this. So here there is the liquid. Okay, here there is the capillary tube, and here there is a stopcock. Here there is the thermometer. Again same thing, this is the sink, to sink, water is inlet, water inlet here. See, in distillation here was the water inlet, in normal distillation here was the water inlet, here is the to sink, because you need condensing, right? So here also same phenomenon, nothing else, no problem over here. So what is happening, I need under reduced pressure I will boil it. So over here it is, here when it is start boiling, it will boil at a normal pressure, nothing is over here, there is no problem. Same, it will boil, suppose it is at the boiling point is 100 degrees C, so it will boil 100 degrees, it will come over here. Now it has came over here, the heated, the distilled liquid. Now before coming over here, as it should boil in 100 degrees C, but here there is a manometer and here is the vacuum pump. Okay, so I am reducing the by using this vacuum pump I am reducing the vapor pressure and external pressure. So I am reducing the pressure. Now at 90 degrees C only, this vapor pressure is equal to external pressure. So when it is in the vapor pressure is equal to external, see, this is external pressure. So what will happen? So at 90 degrees C, see the pressure here, the pressure is, they are checking, the pressure is reduced, okay. So by reducing the pressure, the vapor pressure is now becoming equal to the external pressure at a lower temperature, that means at 90 degrees C only. So it will boil at 90 degrees C and we will get the distilled liquid over here. Okay, so this is the setup. So suppose setup can come, setup is given, what type of setup it is. Okay, same thing. Or you can expect another question like that, there is this setup is given and you will be, after this setup is given, you will be asked that by this method, option A, spent lye is separated from glycerol point. So like this there questions can be, or there it can be that this method is used to separate two volatile liquids having different boiling point, two volatile liquids having same boiling point, or one volatile liquid which will decompose at low temperature, which will decompose at lower boiling point temperature. So all this. Now the stream distillation, and this technique is applied to separate substances which are stream volatile and immiscible with water. What? So for suppose you are given that there is this type of mixture, what type of distillation or what we will use? So what this method is used to separate what, it is very important. So the substances which are steam volatile and immiscible with water, two criteria it should match. One is steam volatile, another is immiscible with water. So in steam distillation, steam from a steam generator is passed through a heated flask containing the liquid to be distilled. There is a liquid which we need to distill. So what we will do? Using a steam generator, we will pass steam into this heated flask. So first I will heat it. See here the diagram is there. So see, this is the liquid. This is the liquid. This is a heating flask. So from here, the water, the steam, we are passing steam through this liquid. Here condensed water vapor is coming out from here, and the heated steam, the steam, that is steam, we are passing steam. How we are passing? You need to generate the steam, right? So for making the steam, water is heated over here. So we are passing steam in the heated flask containing the liquid which is to be distilled. Okay, The mixture of steam and the volatile organic compound is condensed and collected. So here it will get collected. So the distilled compound to be distilled, they are along with the steam, it is condensed. So this is the condensed, it is getting condensed. Here the condenser, it is getting condensed and collected. Okay. Now the is condensed and collected. Now the compound is later separated from water using a separating funnel. In steam distillation, the liquid boils when some of vapor pressure. So this is a very important thing. The liquid will boil when sum of vapor pressure due to the organic liquid rho 1, pressure 1 and rho 2, okay, or P1 and P2, okay, and due to water P2 becomes equal to the atmospheric pressure. That means P1 is the pressure of the vapor pressure of the vapor pressure due to organic liquid. P2 is the vapor pressure of the water. So when P1 plus P2, vapor pressure of the water and the vapor pressure of the plus the vapor pressure of the liquid, it is becoming equal to the atmospheric pressure or the external pressure. When this is happening, the liquid will vaporize at lower temperature than its boiling point. Thus, if one substance in the mixture is water and the other a water insoluble substance, then the mixture will boil close to but 373 Kelvin. The mixture of water and can obtained which can separate using a separating funnel. Aniline is separated from aniline water mixture by this method. So by this method, what is happening? Who are separated? Aniline is separated from water. So aniline water mixture is there. So we will separate this using aniline water. So by we will have to use last and we need to use a separating funnel. Okay. So when what is they are saying? The thing is that vapor pressure whenever is equal to the external pressure, then only a liquid will boil. So if one substance in the mixture is water, the other a water insoluble substance, then the mixture will boil close to, so that when the vapor pressure of water plus the vapor pressure of, that means P1 is equal plus the vapor pressure of the compound, this is equal to external pressure. Okay. So now the boiling point of the liquid is much more higher, but now the liquid will boil at 373 K, that is equal to 100 degrees Celsius, boiling point of the liquid. Okay. So the liquid having a very high boiling point is now actually, suppose 120 degree only I am saying, it is having very high boiling point 120 degrees C than water, but now it is boiling at lower temperature like the previous one. So what is happening? We will get a distilled liquid. Okay. And we are using this to use aniline water mixture. Okay. Now in the part 3 of this class, we will discuss differential extraction, okay, and the chromatography. This is a huge part. This is a very important part, especially the chromatography. So you have the distillation, the chromatography. Chromatography is there are various types of chromatography, and this is a very important part. And by this we will finish the chapter, the purification of organic compounds. Thanks for watching and stay tuned. And stay tuned for third part. Okay. Actually, my handwriting is not at all good, and because I am writing very fast. Hopefully, during taking the classes which are the theory classes where I need to write huge, that is the physics classes where we need to solve questions. I will try to maintain the handwriting speed so that you understand better. So keep watching. In the next part I will complete the purification of organic compounds. Thank you.